Welcome to Business Statistics, CRX 1003. And today lectures, we will discuss discrete probability distribution, and we will discuss on binomial and the Poisson distribution. This lecture contains discrete probability distributions. We will look into the covariance formulation in order to analyze the relationship between the two variables. And then we will look into that binomial probability distribution. And we will look into the rules of combinations. And finally, we will discuss about the Poisson distributions. All right. Random variable, as you know, that is a numerical descriptions of the outcome and experiment. And we already discussed this in the previous lectures. So random variables, which means we choose that samples from that populations randomly. Okay. The random variable can be classified as being either discrete or continuous, depending on the numerical values it is assumed. For example, discrete type of the variables is something which is exact value and just can be counted exactly. However, for the continuous, it could be in the form of range or could be in the form of decimal numbers. Okay. So we'll look into that, some example in a while, and in order to clearly identify what does it mean the discrete and the continuous. Okay, random variables. So as you just mentioned, random variables is classified into the two groups. One is the discrete random variable, which is that finite numbers of values or infinite sequence of values. Okay, so if you represent that the discrete random variable, we can use that histogram, or we can use a bar chart in order to show that the frequencies values for each class set. Okay, the frequencies of each class set. For the continuous random variable, usually it will be on the numerical value in the form of interval, and we also can call as the collection of the intervals, and it can be represented in the form of curve. Okay, if you can see that the discrete is a bar chart. Okay, you can see the bar chart. If it is the continuous random variable, in the form of curve. All right, so that's how we can differentiate between these two types of the random variables. Today lectures, we will look into that discrete random variables, and the analyze will be revolved around this discrete random variables, which means, as I said earlier, it will be on the method we use for the binomial and as well as the Poisson distributions. All right. The probability distribution for the random variable describe how the probability are distributed over the values of the random variables. Okay, so we will look into that some example in a while in order to see that how the discrete random variable is distributed. And usually that the probability distributions defined using a function which is usually we call as a px. All right, so p stands for the probability and the x is the random variables. Okay, and it's also required the condition. All right, so it's come out the two main conditions. First is the probability of random variables has to be greater or equal than 0, and as well the sum of the probability value must be equivalent to 1. So these two conditions has to be fulfilled in order to meet the requirements. Okay, so always need to check when you just develop the frequency table, and the sum of the probability has to be equal to 1, and the probability itself has to be greater than or equal to 0. All right. So we also can describe the discrete probability distribution with the tables, all right, a graph, and as well as equation. So these are three main channels we'll be able to describe the probability distributions. All right, now take a look at the steps we follow in order to develop the discrete probability distributions. Okay, the first steps So we need to make that frequency distributions, right, for the possible outcomes. So we all know they get a data and we know that the frequency of the distribution. Next, we need to find the sum of the frequency. So each set of data, so we know that the sum of the frequency, how much we have, all right, for each category. And then we need to find the probability of the each possible outcomes by dividing the frequency by the sum of the frequency. So once we identify that the number of frequencies in the particular class, so then we divided the total number of frequency or total number of entries. So then we are able to get the probability value corresponding to the each class that we look for. Okay. All right. Now, at last, we're going to check the probability between is a 0 and 1, and then we're going to calculate the sum of the probability, which must be equivalent to 1. Okay, so when we add all the probability value, then we will get the total of the probability will be equivalent to 1. Okay, so these are the 4 steps you need to remember, and this is the guideline in order to develop the frequency table. All right, now take a look at this example. Okay, take a look at the example. So you are given 2 coins, okay, and then you're going to look for all the possible outcomes. Okay, say for example, this question, they're interested to know that the number of heads popping out when you toss the coin. Okay, so for that, the subject, okay, the requirement or the objective of this events to get the number of heads. Okay, so that you can express, or maybe you can assume that the x, all right, as the number of heads you obtain. Okay, let the x the number of x obtained. So you can represent the x value in order to express that the subject or the objective of that the experiment. Okay, now we have 2 coins. Now we're going to obtain all the possible outcomes. So first things, you can use the tree diagram in order to see that all the possible outcome. So how are you going to develop the tree diagram? I'm sure you all know about it. So I have taught you in the previous classes. So the tree diagram, I'm sure tree diagram is in what situation we can use the tree diagram. So now we have 2 coins. So we can choose that the 2 coins as a problem, which is we can represent that by using the tree diagrams for all the possible outcomes. All right, now take a look at this tree diagram. So this is the first coin you toss, you get either head or tail. So the possible outcomes, you're getting a head is a 1/2, as well as for the possible outcomes to obtain the tail, you get a 1/2. All right, and then you toss again the second coin, I mean the coin 2, that is a possible outcomes is 1/2 as well, you get a tail 1/2. Or so you maybe this is you get a set the coins you appeared a head or tail. Okay, for this option when the first coin appeared to head and tail. All right, all right, so if you see that all the possible outcomes, okay, so you can list down. Okay, there is a possibility the 2 coins appear to be head, or the 1 coin appear to be head and another one is a tail, or the first coin appear to be tail and the second coin appear to be head, and the third or fourth options, the both coins appear to be tail. All right, so then you can see that the formulation, so half times half. All right, so this is a union, so which means the H means H and H. Okay, so H, the and, as I already mentioned the previous classes, that intersection, this is supposed to be multiplying. Okay, the probability is multiplying. So you need to multiply the fraction, you get a half. Okay, as well as goes to others. Okay, now next, we can illustrate this all the possible outcomes. So if all possible outcomes, you may get by tossing the 2 coins. All right. So we have a 2 tail. okay, one tail and one head, or one head and one tail, or both is head. Okay, now take a look on this. Now we're going to represent all these possible outcome into a frequency table. All right. So in order to develop the frequency table, as we know the X value. All right. So this is that number of heads. We need to highlight that. So we have a 0 head to be happier. Okay. Or 1 head to be appeared, and the 2 had to be appeared. Okay. So all the X random value, okay, 0 had to be appeared, and 1 X random variable, which is 1, had to be appeared, and 2 had to be appeared. So this is how we can simplify it. Okay, now based on this, we can get the probability distributions and the probability value. Okay, as we know that the total probability we obtain is 0 is a 104. So we two tails, so you can look at that. All right. So this is the value. So 104. So we get a 0.25. And we have two events or two possibility we get a head. So one is tail head or head tail. So that is a 2. So that means 2/4. So we get a 0.5. And then we get a 2 head together. So this is like this one. So it means 104. Okay. So you get a 0.25. So now if you just add this up, all right. So sum up of all these X. So the probability, so you will get the equal to 1. So you just count that 0.25 plus 0.5 is 0.75 plus 0.25, you get a equal to 1. So this is sum of the total probability has to be equal to 1. And then the condition 1, this is condition 2. The condition 1, you see that your probability, okay, is greater or equal than 0. So condition 1 and condition 2 is already fulfilled. All right. Now, if we just represent in the form of the graph, you can see the graph, the bar chart, we show that the frequency 0 is a 0.25, and frequency X is equal to 1, it will be shown as a 0.5, and when X is equal to 2, they show it as a 0.25. Okay, so this is the way how we're going to come up with that solution for the coins, 2 coins when it's closed, and all the possible outcomes. Okay. All right, now moving on, expected value. Okay, the expected value, or we call it a mu value or mean value of the discrete distribution. Okay, in other words, it's also called as a weighted average. Weighted average. So the formula for the weighted average is represent the mu. All right, this is a mean value. Okay, or mu. Okay, is equal to EX. Okay, EX. It also can be expressed in this form, EX. Okay, the average value of the probability equivalent to sum of xi multiplied by pxi. That means this is a probability. Okay, px is a probability, and this is that the x is your variables, which is represent the corresponding to that the probability. Okay, all right. Now, for example, just now we used that the previous example as a guideline. So we use those problem in order to obtain that the expected mean. All right, now take a look how we're going to solve that. Okay, as we know that the probability of that each random variable x 0, 1, and 2. So we have that the corresponding value of the probability, which is 0.25, and we have a 0.5 for that when x is 1. So when x is 2, we get a 0.25. Okay, now expected value, as I said, you need to multiply that x with the corresponding value of the probability. So which means, so you can now you're going to sum up the x times your probability of x. So I make it simple. So 0 multiplied by 0.25. Okay, just multiply. All right. So and then plus, and we're going to multiply 1 with the 0.5. Okay. The second one, okay, and then the third one, so 2 times, okay, plus 2 times 0.25. Okay, now you need to add them up everything. So this is 0.25, you got a 0 plus 0.5 plus this is will be equivalent to 0.5. Okay, and if you add them up everything, then you will get equal to 1. Okay, all right, so this is that the expected mean value, which is 1. Okay, is clear? All right, I hope you just clear on this. Right, moving on. Now, variance. Now, take a look on this variance. All right, so variance is a discrete random variable and is also summarized that variability in that value of the random variables. Okay, so in order to calculate the standard deviation or variance in the discrete random or discrete probability is very simple. So use a formula. So the sigma square equivalent to sum of in bracket x I minus ex in the bracket whole square multiplied by px I. So this is the formula you got to know, okay, in order to find that the variance. If a square root of that the variance is a standard deviation. Okay, so what all you need to do is you can square root that the variance and you will get the standard deviation. Okay, do you still remember what does it means that the standard deviation? Yes, of course, it's error. All right. I hope you still remember that. Okay. The error, which means we see if you the division is smaller, that means it's a small error. If it is large numbers, then it's a high error. Okay. Variance is usually we go for that the variability, whether it's low variability, whether it's a high variability. Okay. Now, again, so this is the formulations in order to obtain, in order to get the standard deviation. If you square root of the variance, then the standard deviation. All right. Now, we use the same example. All right. So just now we already know that the expected mean is equal to 1. Remember that. Okay. So now we're going to compute the standard deviations for this problem. Okay. Now, as we know, the formula, as just mentioned just now, so we just use this formula, okay, in order to obtain that the standard deviation. Okay. Now, as we know that the random variable 0, we have a corresponding value which is 0.25 for the probability. Okay, just right here. So this is x, random variable x. So 1, you get a 0.50. And when the x is 2, you get a 0.25. Okay. So now the 0 minus the expected mean. As we know that is mean is 1. Just now we calculated in the previous slide. So the expected mean, or we call it mu, all right, it's equivalent to 1. So we have that the 0, okay, the x minus 1, the mu 1. So mu, which is 1. So square multiply by the corresponding value of that, the probability when the x is 0. So it should be 0.25. Okay, plus 1 minus 1. So 1 minus the expected mean is 1. So whole square. And then multiply by 0.25. That means the corresponding probability of random x variable, which is 1, is a 0.5. You just substitute here. Plus 2 minus 1. So 2 random variables, 2 minus 1 expected mean. So whole square multiply by 0.25, which is you obtain from here. So you get a 0.25, and altogether you calculate, simplify, you get a 0.50. All right. So if you square root the 0.50, then you get a 0.707. So that is your standard deviation. Okay. So that your standard deviation.